and we're going to talk a bit about how cloud data lakes and cloud data warehouses can work together, how they're different and common. And this topic is one that we've heard a lot about at Cazena. We have some awesome architectural talent and some awesome writing talent. Our data architect, Venkat Chandra, recently wrote an article for Datanami, and he says, while cloud data warehouse and cloud data lakes may solve disparate issues, they can and should complement each other. So used in tandem and backed by the power of the cloud, these two architectures can more fully harness the complete data and analytics picture to deliver the value and business insight that enterprises continue to seek out. If you read his article, he goes into exactly what a cloud data warehouse is and what a cloud data lake is, and we talk about how they can work together. So this whole concept has given us a lot of people have been asking us a lot more about cloud data lakes and cloud data warehouses. So Levan and I have been thinking a lot about this and how to talk more about this concept. And Levan, we did a little homework on the web to look at how some cloud data warehouses describe their architecture and where in their architectures and reference architectures cloud data lakes can fit in. So with that, I'm going to stop talking and take it away, Levan Chetty with Cazena.
Thanks, Anna. So yeah, this topic comes up a lot in conversation with customers, and I think the data warehouses is a concept that people are very familiar with. They're used to dealing with structured data, and SQL is a very widely used language. So they typically have existing teams of people that can interact with that. But I think where the augmentation with the data lake comes in is a lot on some of the newer sources that are starting to come in. So for example, there's two that come to mind from our customer base. One is a customer that pretty extensively mines the log files of their websites, and that input of data that's coming in is not nicely structured, right? Because those applications just have streams of text that are in these log files. So there's a reasonable amount of processing that needs to occur to mine the important portions out of those files and turn it into structured data, right? So there's that initial step of how do I get to the structured data that a data warehouse can now start to manipulate and have my users run queries on, because I can't run a query on a text file that has no format in it. Or no easy format, I should say. So that's one example. And then another example is, the proliferation now of companies that are starting to adopt IoT technologies, right? So we have a couple of customers like this, where they're starting to deploy sensors on production lines. They're starting to deploy some of these devices that start to collect data for them. So, so there's two components there. The first is, where does that data go, right? Because you've now got just these little snippets of data coming in, at random points in time. You can't just decide, hey, I'm gonna collect them every so often, because it's the data is coming to you, right? So you're not pulling it in anymore. So there needs to be a place where you can persist that and then start to process it, because again, these messages that are coming in are fairly disparate because they're usually devised by the manufacturer of the device, right? So again, you get into that same process of how do I now mine the relevant information out of all of these disparate messages to now give me some structured data that an end user can start to interact with, right? So I think that's where data lakes become very complementary, right? Because it gives you a place to ingest all of this disparate data in a variety of formats, whether it's structured or not. And then it gives you some really powerful tools to be able to manipulate, wrangle, conform, cleanse data, so that you get to a point of where this is now structured data that you can stick a SQL statement onto.
That makes sense. And marketing, we know a lot about dealing with different disparate data types. We're looking at things coming from the website, or we look from logs at the website and analytics. We're trying to nip that all together. So I can really empathize with this issue.
Yeah, and and so I think that one of the reasons that these questions come to us a lot is we've got companies that we're chatting to who have adopted some of the cloud data warehouses that have done a phenomenal job with the with the SQL engine like Snowflake, right? And one of the great things they do is they're giving customers a SaaS delivery mechanism, so the customer doesn't have to know how to install, configure, manage, and monitor the database engine, right? But if you have to do all of this ingestion and pre-processing by yourself, then you're back in the DIY world of having to figure out, well, how do I put all the pieces together to be able to ingest all of this stuff, and then have all of the processing engines that I need to do all of that pre-processing of the data, right? So if you're picking a SaaS delivery mechanism for the data warehouse, right? Then then you probably want something equivalent for the data lake side of it as well, because you don't want to then end up in this in the state where you're going to have to go and figure out how to put all these pieces together and then monitor them and make them secure and manage them and keep them healthy. So if you look at the reference architectures for a lot of the data warehousing solutions, you'll usually see that there's typically a reference architecture that has this ingest and prepping in front, and then some of the machine learning and statistical analysis components that would come in after that, right? And so so for an end-to-end pipeline to occur, you're going to have to go through all of those steps, right? You're going to have to go through ingest, cleanse, wrangle, then you get to query, and then post-query, you might end up starting to do the statistical analysis. So so augmenting those those non-structured cases with the data can usually then enable you to do that entire end-to-end pipeline.
So then we come to with the cloud data lake and the cloud data warehouse together, especially with a instant cloud data lake. How does that work, and how does that make things easier?
So I think that goes all the way back to that delivery mechanism, right? Which is that if you're not interested in all the low-level plumbing and trying to figure out how do I secure networks and how do I keep the lights on, right? Then having the instant data lake gives you the same delivery mechanism, which is all SaaS, right? So it's all about you focusing on the data. What data should I be ingesting? How should I cleanse this data? How do I conform data, rather than thinking about, well, how do I keep my Spark cluster up? How do I do authentication and authorization? How do I ensure that all of my data is encrypted? So there's a lot of plumbing that goes along with that. So taking an approach of the instant data lake means that you just focus on data and analytics, right? And you don't have to worry about all of the complicated underlying infrastructure and plumbing that goes along with enabling that.
Okay, and so our theme today is data modernization. How does using a cloud data warehouse and a cloud data lake together empower data modernization? And what does that term mean to you as somebody who's more focused on the architecture?
So I think that a lot of the modernization that we see, especially with our customers, is just the variety of data that is starting to change, right? If I look 10 years ago, the majority of data that these companies were consuming were from internal databases, right? And so they were all nicely structured because they were in an internal database. So having just a data warehouse then worked, right? You had structured data going to structured data. But today, it's not just those examples of the log files and the IoT devices, but it's also a huge proportion of data is now getting purchased, right? We all know about this, which is all of these companies that are collecting data about every aspect of our lives and other people's lives, right? And those are all being purchased all the time. So that variety of data, you don't have control over what formats that data is going to come in, how frequently it's going to come in. You just have to accept what the vendor is going to provide you. So you need that flexibility. So I think that that's really part of how I see that modernization, right? Which is that on the first step, it's how do I get the flexibility to deal with all of these disparate sources? How do I get to deal with the disparity of skills as well, right? Because skills are also morphing radically. languages like R and Python are now taught in most universities, right? So the people that are being hired into these organizations are not just coming in with SQL skills, they're coming in with R skills and Python skills and Scala skills. So you need to be able to give them a place in which they can manipulate data in the languages that they understand best, because that's going to be the most efficient for, for these companies.
I like it. That's a great answer to the data modernization question. And I think we have some more resources here, and we'll send these around to everybody for after the call, more about cloud data warehouses versus cloud data lakes. Anything else you want to add on this discussion, Levan, or any other resources you'd recommend people look at to learn more?
Yeah, I mean, I think there's some good blogs that have, Sides Venkat's blog, I think is a great one, to start with. And there's also some really interesting blogs on the AWS website, so maybe we could link to those on ours as well to make it easy for people to get hold of those resources.
Great. Well, thanks so much, Levan Chetty, VP of Product with Cazena. Thanks for joining us today.
Pleasure, Anna. It was fun.